Hello Geometry, this is lesson 5.2, congruent polygons. The essential question that I want you to have in mind is, given two congruent triangles, what can you conclude? Okay, so for the first example here, we're going to be talking about write a congruence statement for the triangles, identify all pairs of congruent corresponding parts. So the congruence statement here says this. This is your congruent statement. So triangle, I don't care how you name this, we'll say JKL is congruent to triangle. Now J has a double arc mark, so the double arc mark needs to go with where the J is. So since J is first, T will be first for the other triangle. And then next was K, so that had the 3 arc marks, so find 3 arc marks, and that goes with S. So T, S, and then we've got R. Okay, so just to make sure that your J corresponds with T, K corresponds with S, L corresponds with R. So this is our congruence statement. Okay, it says then identify all congruent corresponding parts. Well, triangles have 3 angles and they have 3 sides. So that means that they have 6 corresponding parts. So let's go through and name all of them. So let's just start with the angles. Angle J, and you can get this from your congruence statement or you can get it from the picture. J is congruent to the other 2 arc mark, which was angle T. Angle K is congruent to angle S, and angle L is congruent to angle R. Okay, so that's 3 parts here. I said triangles technically have 6 corresponding parts because we also have sides too. So let's just start with one of the sides. So we'll do the 1 dash mark here. So JK is congruent to the other 1 dash mark, or you could line up, we said JK, so that's going to go with TS. So JKTS. And then we've got KL is the 2 dash mark, so go to the 2 dash mark, and that's SR. And then our last side is JL is congruent to RT or TR. Okay, so this is all of the corresponding parts. So make sure that you're answering this question fully. Example 2 says in the diagram DEFG is congruent to SPQR. Find the value of X. So there's a reason why they actually want you to find the value of X first. The second one, they want you to find the value of Y. So here is where the Y is, but notice it has an X involved. So they want you to find X first because we actually have to find X first for that. So now you have to decide, are they talking about a side or an angle? Okay, well, this 2x minus 4 represents a side because it's labeled as feet. So this is side QR. So QR in your congruent statement will correspond to FG. So it's so easy to make this correspond to 8, but it's actually not. That's not what it is corresponding to. QR is corresponding to FG, which the figure is flipped around. So that's to 12. So what you're going to do is these are corresponding, which means that they are equal or congruent to each other. So we've got 2x minus 4 is congruent to or equal to 12. Add 4 and then divide. You get x equals 8. Now they don't want you to plug it back in. They just wanted the value of x, so we can stop. Now the value of y we talked about right here. Now look at how this is labeled. The y, the 6y plus x, that is a degree. So that means that we're talking about an angle here, and we're talking about angle Q. Well, angle Q corresponds with angle F. So let's find F here, and it's 68. So what you're going to do is you're going to set these angles equal to each other because Q corresponds with F, and they are congruent to each other. So 6y plus x equals 68. Well, what's so nice is we already know what x is. So let's just replace that. 6y plus 8 equals 68. Now solve for y. Subtract 8. And we get y is equal to 10. Once again, they just wanted the value of y. Okay, so it says you divide the wall into orange and blue sections. The orange and blue sections along JK. Will the sections of the wall be the same size and shape? So in order to be congruent, they have to have congruent corresponding angles and congruent corresponding sides. That makes them the same size and the same shape. So let's just look at this here. We have that we've got this side being congruent to this side. So AJ congruent to KC. We've got DK being congruent to JB. And we have DA being congruent to BC. Well, JK is equal to itself. So JK is congruent to JK. Why? This is reflexive. So this is going to come back a lot in this chapter. So JK is congruent to JK by reflexive. So we're going to put 4 there. So far, all sides are congruent to each other. Okay, so now let's look at the angles. Well, we've got a right angle, a right angle, right angle, right angle. So A goes with C and B goes with D. And then we've got, basically, if these are right angles, we have that these lines are parallel to each other, which makes 3 and 2 congruent and 1 and 4 congruent by alternate interior angles. So since all of the angles are equal and all of the sides are equal, yes, these are. It says, will the section of the walls be the same size and shape? And you would say yes. Okay, all sides are congruent and all angles are congruent. Once again, we can say that 2 is congruent to 3 by alternate interior and 4 is congruent to 1 by alternate interior angles. So all sides and all angles are congruent, which, yes, makes these wall sections the same. So now let's skip ahead to these theorems. So properties of triangle congruence, you guys have seen reflexive before. Just make note that reflexive looks like this, okay? When something is equal to itself. Symmetric, if triangle ABC is congruent to DEF, well, DEF is congruent to ABC. And then you've got transitive. If ABC is congruent to DEF, but DEF is also congruent to JKL, we can set ABC and JKL equal to each other since they're both equal to triangle DEF. The third angles theorem states that if you have two corresponding angles with two triangles, you can automatically assume that the third ones are equal to each other. Okay, so for instance, if you had two triangles here, and you said that this was 60, which was congruent to this angle, which is also 60, and we were given that this was 40, which this one's congruent to that. If you look at these, if you've got 60 and 40, there is only one measure that is left for these two to be, and these are congruent to each other by this theorem. And if you think about it, 60 plus 40 is 100 minus 180. That only leaves one angle measure. It's not like there's multiple measures that could be, okay? So as long as two of the angles are given to be congruent, the third ones we can assume will be congruent without doing any math. And that's the third angles theorem. So let's look at this. It says find the measure of angle BDC. So let's just mark that BDC. Okay, that's this angle right here. Now, when you're looking at this, I want you to think about this large triangle here. Okay, BDC is going to correspond to this large triangle here. And it's going to correspond to ACD. Okay, so now what you want to do is you kind of want to look at each triangle one at a time. And I noticed that this is 45 degrees and this angle is 30 degrees. So if you've got a triangle, and I'm just going to kind of draw this off to the side, maybe you're not quite seeing it yet. If you have a triangle that has 45 and 30, well, what you can do to find this last one is you can add them together. That's 75. To find this missing angle, you're going to take 180 minus 75 to get 105 degrees. So we have just found that this angle right here, this entire angle is 105 degrees, which means that this angle, BDC, that we were trying to find is also 105 degrees. So the measure of angle BDC is equal to 105 degrees. Okay, and if you want to pay close attention, we've got a 1 arc mark, a 1 arc mark. You can't see it because I wrote all over it, but these were doubles, okay? You can automatically assume that the third angle is going to be congruent to each other based off of what I showed you right here, that third angles theorem. Okay, so it says use the information in the figure to prove that these triangles are congruent. We are not going to do a two-column proof. We are just going to go through and talk about everything that's given. So let's just attempt the sides first, okay? So let's just look at the sides. We've got that DA is congruent to BC. We have DC being congruent to AB. So the last side that is left is AC. And I want you to write down that AC is congruent to AC. Now this is something that I want to start becoming automatic to you. When you see something equal to itself, this is reflexive, like looking at your reflection in a mirror. Okay, so we have all three sides being congruent. Let's now go to the angles. So angle DAC is congruent to BCA. That's a 1 arc mark. And then we've got a double arc mark here. So then now we are left with these last angles. And we can actually say that angle D is congruent to angle B. Why? Once again, because of that third angle theorem. If you've got that two of the corresponding angles are congruent, then the third one can automatically be assumed. So third angles theorem. So since all corresponding parts are congruent, then triangle ACD is congruent to triangle CAB. So when you are talking about that essential question of given two congruent triangles, what can you conclude? That all of the corresponding parts will be congruent to each other.